Hi class, today we're going to be going over wave formulas and calculations. I'm covering slides 22 to 26 in my PowerPoint titled Chapter 17 Mechanical Waves A. You can find that in the page marked Class PowerPoints. We know that speed, the variable is V. It's measured in meters per second. And with waves, we can calculate in one of two ways. Wavelength is equal to, is lambda for the variable. It's going to be a distance, so it's measured in meters. And if you multiply it by the frequency, which is measured in hertz, hertz is the number per second of waves that occur. And so we can calculate speed is equal to the wavelength times the frequency, or we can calculate the distance of the wave and how long it takes to travel that distance using V equals wavelength divided by the period. So the period answers the question of how long for one wave, while the frequency answers the question of how many in a given period of time. Frequency is the inverse of the period. So frequency is 1 divided by the period, or you could rearrange this and say that the period is equal to 1 divided by the frequency. I know some of you guys really like using the triangle to help rearrange these equations. So our first triangle would have wavelength times frequency all over speed. And this second equation up here, we would then have the wavelength, lambda, divided by the period and speed on the bottom. So I'm going to erase this really quick and I'll be right back with you so we can go over practice problem. So the first problem is on slide 24 in the PowerPoint. It says that a wave in a spring has a wavelength of 0.1 meters. Now this unit meters is going to be the unit for the wavelength. So I'm going to assign that to lambda, the variable of wavelength. And the question then says, in a period of 0.2 seconds. Now, period is the variable t, and so we have 0.2 seconds. It goes on to ask, what is the speed of this wave? So we are then solving for v. So we know that the speed of a wave, given these variables, would be equal to the wavelength divided by the period. And so I'm going to plug into this equation my information. 0.1 meters divided by 0.2 seconds. Take the calculator, 0.1 divided by 0.2, you would get that being equal to 0.5. And for my units for speed, it is meters over seconds and nothing cancels, so I would put m/s for my unit. That is problem 1. Okay, practice problem number 2 from my PowerPoint on slide 25. It says find the wavelength of a wave. So we're looking for lambda that has a frequency of 2.0 hertz. So the frequency is 0.2 Hz. Now what this really means is that we actually have 0.2 waves per second. Okay, and that's going to be important in canceling units in order to get our unit for wavelength later. And then we have speed is 0.4 meters per second. So we need to use speed equals wavelength times frequency, which if you're using the triangle to rearrange this equation, speed's on top and wavelength and frequency are on the bottom. And so the wavelength would be equal to the speed divided by the frequency. So we're going to plug in our information here. 0.4 meters per second divided by 0.2 per second, or 0.2 hertz, and we will get an answer of 0.2 meters with seconds canceling.